students. We're going to go over chemistry crash course, implementing MCAT requirements, amino acids, beginning-friendly education. So hi everyone, let me start with something simple, but kind of wild. Everything you see right now, your hands, your phone, is the air you are breathing, even your thoughts happening inside you, your brain. This is all chemistry. Not in complicated hard exam way, but in a very real physical sense. Atoms interacting, electrons moving, bonds forming and breaking. And today we are going to do something important. We are going to take a full journey. First, we quickly refresh high school chemistry, and not in a complicated hard exam way, in very real physical sense. And today we are going to do something important. We start thinking like MCAT students. People who connect chemistry to life and medicine, young Americans. And in the end, we're going to step into one of the most important ideas in biology, amino acids. Building blocks of proteins and basically the building blocks of you. So if chemistry ever felt disconnected from real life young Americans, this video is where that changes. And now let's go into it. Let's start at the smallest level. Everything is made of atoms. An atom is the smallest unit of matter that still keeps the identity of an element. So atom, you by looking into atom, you can tell where it's coming from what thing, from what chemical element it is coming from. So it's you can still recognize it in that way. It keeps identity, young Americans. Inside every atom, you have three main particles: protons, which are positive, neutrons, which are neutral, and electrons, which are negative. Now, here's the most important part. In chemistry, electrons do almost all the work. So in chemistry, electrons do all of the work. If you remember only one thing from this section, remember that. Electrons are the reason atoms bond, react, and form everything in the universe. Now, atoms don't exist randomly. They are organized in something called the periodic table. You remember from your high school periodic table in your chemistry classes. If not, refresh your memory. Look it up. On the left side, we usually have metals. Metals tend to lose electrons. On the right side, we have non-metals. They tend to gain electrons. Right side, non-metals gaining electrons. Metals losing electrons, And when a metal meets a non-metal, something interesting happens. For example, sodium is a metal, chlorine is non-metal. Sodium gives away an electron, chlorine takes it in. And together they create something which is called sodium chloride. Table salt, young Americans. So even something simple as salt is just an electron behavior at the atomic level. That is chemistry, young Americans, and chemical bonds. Now we move one level up. Atoms don't just float alone; they connect through bonds. There are two main types of bonds. Ionic bond. There are more, but the two that you need to know is ionic bond and covalent bonds. The ionic bond is when one atom completely gives up an electron to another atom. So one becomes positive, one becomes negative. They attract like magnets. It's a transfer system. Now covalent bonds are different. Instead of giving away electrons, atoms share electrons. Think of it like two people holding a ball together instead of one person throwing it away. That shared relationship creates stability, young Americans. Now there is one more idea that is extremely important, especially for biology: polarity. Polarity happens when electrons are shared unevenly. So one side of a molecule becomes slightly negative and the other becomes slightly positive. A perfect example is water. Water is polar. And because water is polar, it can dissolve many substances, support life, and allow chemistry inside the cells to happen. Without polarity, life chemistry basically wouldn't work. So here's a simple way to remember this whole section. Ionic equals transfer, covalent sharing, polar uneven sharing. And all of that is how molecules are built. Chemical reactions, how change happens. Now let's talk about reactions. Chemical reaction is just atoms rearranging. Old bonds break, new bonds form. But there are something very important happening in the background, and that is energy. Breaking bonds away requires energy, consume energy. Forming bonds releases energy. So every reaction in chemistry is really an energy story. We classify reactions in two main ways. Exothermic reactions release energy, usually heat, and endothermic reaction absorb energy from the surrounding. So you can think of it like this: breaking is expensive, building pays you back. And I don't know if it's a good analogy or not. And life depends on carefully controlling both. Your body is constantly running thousands of reactions per second. So you got thousands chemical reactions per second, managing energy like a very complex machine. Acids and bases, young Americans, it's a chemical balance of life. We're gonna go now. Let's move into acids and bases. This is where chemistry starts feeling very biological. An acid is something that donates hydrogen, ions, H plus. A base is something that accepts hydrogens. Now, why does this matter? Because hydrogen ions control acidity, young Americans. We measure acidity using something called pH scale. The scale goes from 0 to 14. Low numbers mean acidic, high numbers means basic, and 7 is neutral. Now, here is an important idea. Even small changes in pH can dramatically affect life. For example, your stomach is highly acidic to digest food, but your blood has to stay very stable around neutral pH. If your blood pH changes too much, even slightly, it can be dangerous. So your body is constantly balancing acids and bases like a tightrope system. And here comes the idea of organic chemistry as opposed to non-organic chemistry. Organic chemistry where life starts. Now we enter, this is where chemistry becomes biology. Organic chemistry is the chemistry of carbon. Carbon is special because it can form 4 bonds. That means it can build chains, rings, and huge complex structures. And that flexibility is why life exists. Now, carbon forms structures called functional groups. We don't need to go too deep, but there are three important ones. OH groups, which are alcohols, COOH groups, which are acidic, and NH2 groups, which are amines. Now keep those last two in mind, because they are going to matter a lot in a moment. And that's because it's the building blocks of life is amino acids. Amino acids are building blocks of proteins. And proteins are what actually run your body, young Americans. Now every amino acid has very specific structure. At the center there is a carbon atom. That carbon is connected to 4 things: an amino group, an H2, a carbon group, COOH, a hydrogen atom, and a side chain called an R group. And that R group is what makes each amino acid different, young Americans. So you can think of amino acids like Lego pieces. So you can think of amino acids as a basic shape of which are different, which has the basic shape but different attachments. Now, here's a powerful idea. Amino acids linked together, they form proteins, and proteins do almost everything in your body. Enzymes are proteins that speed up reactions. Muscle fibers are proteins. Every part of your immune system are proteins. So in a very real sense, you are built out of amino acids arranged into proteins. In life, at its core, is just organized chemistry. So let's bring everything together. We started with atoms, then bonds, then reactions, then acids and bases, then carbon chemistry, and finally amino acids, the foundation of proteins. And here's a big takeaway. Chemistry is not separate from life. Chemistry is the explanation of life, young Americans. So if you understand amino acids, you are not just learning school material. You are stepping into biology, medicine, and you are using MCAT level thinking. And then the next lessons will go deeper into how amino acids actually connect together to form proteins, and how those proteins control everything in the body, young Americans. And thanks for watching.